Yeah, so a very good evening, everyone. Welcome to the today's webinar, where we will explore a fascinating and a highly relevant topic: do software engineering principles apply to data science projects? In a rapidly evolving technological landscape, the field of software engineering and data science often intersect and intertwine each other. As organizations increasingly rely on data driven decision making, the question arises, can the established principles of software engineering enhance the development and execution of data science projects? Our distinguished speaker, Mr. Arup Dattaroy, will delve into this topic, shedding lights on the similarities and differences between these two domains. With extensive experience in both software engineering and in data science, Arup is uniquely positioned to offer a valuable insights and practical examples. So Arup has over 32 years, overall 35 plus years of experience, out of which 32 years of experience delivering successful information management and business analytics projects in multi-terabyte environment, managing analytics Center of Excellence. He is a production engineer graduate and an MBA in finance and systems from premier institutes. He has rich international experience in US, UK, Singapore, and India. He had been a principal consultant driving RFX-led growth for data and analytics practices, the largest practice unit of the large Indian IT service organization. He is expert in solutioning data-driven engagements to offer advisory, development, and operation services in data integration, IoT analytics, and AI ML. He is very passionate about helping organizations in their digital transformation pursuits to derive value and value out of the data and to emerge as the data driven organization than simply being there as an organization. So please come together to welcome and listen, get the good insights from Arup with respect to the today's topic, that is, do software engineering principles apply to data science projects? Over to you, Arup. Thank you.
Yeah, thank you, Dr. Pallival. Thanks for the introduction. And I feel privileged to be part of this series of webinars, which Symbiosis Center of Skills Development is arranging as a precursor to launch a very flagship diploma program in decision management. We'll talk about that a little later. Coming to today's topic, there is a common myth that software engineering principles can only be applied to software development, application development projects. But we'll see little bit more detail on this particular topic. But before I go to this particular delve into the actual topic, let's first try to understand where are data science projects being applied, right? So let's understand that. That will give us a good context to delve into our actual talk. So if I look at application areas, so based on the data which I'm going to display is based on a survey which was done around 4 years back in terms of what are the areas where data science projects are being applied. So we can see like cross-sell, upsell kind of situation. Almost 47% of the respondents mentioned that is the area where data science projects are being applied. Campaign management is the second. Customer acquisition, budgeting and forecasting, attrition, churn, retention. So these are the various areas which the respondent identified where they see the applicability of data science projects. Now, when you talk about these application areas, what are the different kinds of data science interventions which are needed in each of these areas? Let's quickly look at some of them. Obviously, this is not an exhaustive list, it's just an indicative list. So, for example, in cross-sell, upsell, you need to analyze your customer preferences, behaviors, basically generate a customer 360 kind of analytics is needed for that, which needs data science intervention. For campaign management, you need sentiment analysis. Now today in this area is about hyper personalization when it comes to campaign. marketing campaign for that matter. So sentiment analysis, A/B testing, when you want to ensure when you are going to launch a new campaign in a restrictive area first and then roll out en masse in other areas. So that is why A/B testing is needed. And all of these needs data science interventions. For customer acquisition, customer segmentation is a very key requirement. For budgeting and forecasting, regression analysis, time series analysis are a key requirement. For churn, supervised classification algorithm has to be built to predict whether a customer is going to churn or not. Fraud detection, again, anomaly detection algorithms are needed. For promotions, again, customer preferences, customer 360 kind of analytics is needed. For pricing, you need a recommendation engine to build so that you can offer dynamic pricing for your products and services. For demand planning, again, regression, affinity analysis, like what kind of products are brought together so that you can plan your demand well into advance, right? So that kind of analysis is required. For customer service, again, customer 360 sentiment analysis are very, very important because, a satisfied customer is going to be a loyal customer, right? That's the idea. For quality improvement, you have supervised classification, even unsupervised algorithms for fault preventing, preventive maintenance and all those kind of situations. You may need those kind of algorithms. For surveys, you need NLP, speech recognition kind of interventions. For supply chain, again, optimization algorithms, regression analysis. And then there are a lot of other areas like image analytics, optical character recognition, named entity recognition from unstructured documents, right? Neural networks. So these are other kinds of data science interventions which are needed. So having known these kind of intervention which is needed in these application areas, a question which may arise that when do you decide to use data science project, right? Is there any indicator to decide that, yes, I need a data science project to build a solution for what is required, right? So yeah, consider using data science projects using AI/ML when you have a complex task or a problem involving large amount of data. That's a key requirement. And then lots of variables, but no existing formula or equation, right? So that is where you probably you decide that, yes, I need a data science projects now. For example, it's a good option if you need to handle situation like this, right? So handwritten rules and equations are too complex, as in face recognition and speech recognition. So that's where you need to involve a data science project, right? Secondly, the rules of the task are constantly changing, as in fraud detection, right, from transaction records. So where you never know what kind of fraud is going to happen next. So your basically the rules and the tasks are constantly changing in such situation. And finally, the nature of the data keeps changing and the program needs to adapt. For example, in algorithmic trading, right, automated trading, energy demand forecasting. So as the demand and supply fluctuates, the data itself keeps on changing. So the model which you are going to develop has to keep adapting to such changes, right? So that is where you have to think about building using a data science projects, right? Now, probably I will have a poll at this point. So, sir, can you launch the poll, please?
Launched.
Yeah. So basically, the simple question like, do software engineering principle as it is applied for other projects also apply for data science projects? And just indicate your option by yes or no. We'll keep some time more for others, all of you to respond. So it seems like everybody is saying opinion has the opinion of that yes, they do apply. Yeah, maybe we can close the poll now.
Ended, sir.
So right now, at least 100% response is towards yes. So let's go with the, rest of the presentation. So, I have posed the same question that data science projects, are they different from other BI or development projects, right? So most of you answered yes, they are similar because you can apply the same data science, software engineering principles. The answer is yes, they are similar because you can apply the similar, software engineering principles, but also no, because the actual, activities when the software development life cycle will remain the same, but the actual tasks and the, workflows and the deliverables are little different from a normal development projects or a BI project for that matter, right? So the answer is yes and no. Um, Now, typically, why yes? Because you can apply, because even a data science project also has to go through the similar software development life cycle, right? You'll start with an analysis phase, then you do a design, then you will actually build, do the development phase. Whatever you develop, you need to test, and then finally all the tested code you have to deploy for production use, right? So it has to go through all those life cycles. But the actual deliverables, actual process tasks are different. That is the reason why it is also not same as other projects. Right? Now, typically, uh, basically enterprise faces, whenever any enterprise faces some business problems from time to time, which needs to be resolved, right? So that is where they may have all the data pertaining to the business, but they don't know how to analyze and derive insights. So as to take the right decision. So that's why probably, the many times the factors which impact such desired business outcomes cannot be found using traditional business intelligence, the descriptive and diagnostic analytics processes or tasks, and are then posed to data scientists to solve, right? Because as we saw earlier, where it has to be complex, a lot of data, a lot of variables are involved, then that is where the data scientists are asked to solve such problems. Now, data science needs to resort to what is called predictive and prescriptive analytics techniques, which comes under the purview of data science as such, right? So both diagnosis of the problem and the solution can be found after considering through all the underlying data to find different patterns, trends, and associations. And these are typically made possible by machine learning and artificial algorithms, which basically helps in, data assisted human decisions and data assisted machine decisions. So ultimately, the objective is to be able to enable the business users to take the right decision at the right time, whether it is human assisted decisions or, automated decision made by the systems on behalf of the people, right? That is the way. And finally, if you think all such problems or decision making scenarios can be either operational in nature or tactical or strategic, right? It can be all the three types of scenarios are involved for such, problem solving, right? Now, when you talk about this operational, tactical, and strategic problems, right? So that is the need to solve organization problems in those three areas by harnessing domain and technology expertise, right? That's where data science projects comes in. So basically, there are these four key traits that are a prerequisite for delivering some data science projects. First one is strategic alignment, so which helps to define roadmaps to use information as a strategic weapon to transform, sustain, and grow business. So that is the strategic alignment portion of it. That is the key. Second thing is execution excellence. So to employ a well-defined execution methodology to embed analytics in operational systems and business processes to enable companies realize the true value of their data, right? That is the second thing. Third thing is business knowledge. Obviously, you need to know your business very well to bring deep functional knowledge that accelerates the generation of domain-specific insights from information and analytics, leading to optimized business outcomes. Right? And finally, you need to employ advanced, well-tested modeling techniques using state-of-the-art technology stacks to address challenging problems for the organization. Now, all these four key traits actually leads to basically help enterprises to achieve impactful business outcomes, which could be either increased revenue, which is the first and foremost thing, or improve customer experience and loyalty, or optimize operating and capital efficiencies, lower costs, and in general institutionalize an analytics capability within the organization, and that is what we refer to as data-driven organization. How you ensure your organization is data-driven. Now, today we are going to mostly our topic today is only about this area, which is to basically I didn't understand what it takes, the process, the approach, and methodology for delivering a data science project, right? That is what is the focus of today's discussion. Talking about an approach and methodology, so data science projects typically use what we call a diagnose to scale kind of approach or methodology, right? So you start with the diagnosis phase where you define the problem and the opportunity, generate a priori hypothesis, and define the analytics path, right? That is the first step. Then in the solve phase, you actually leverage analytics, right? So you develop, validate, decompose all the baseline data. Then you develop models, quantitative models, and then iteratively refine those models. So the modeling is just not a one-stop shop thing, right? You have to keep on, iteratively refining the models till you until you get the required precision and the performance, right? So stakeholder interviews are required, market research is required during that time, hyperparameter tuning is needed at that point in time. Finally, whatever the models generate the insight, you communicate those insights to the stakeholders. You set the strategy and inform others how you're going to go about implementing those models. You target quick hits and pilot tests, prioritize the decision items, and adopt a measurement approach to check that your models and algorithms are working fine. And finally, you basically think about deploying the models and algorithms in production, so that we basically build an automated process to enable the use of analytics recommendation. You persist the analytics output for dashboards and downstream usage, so embedding analytics in the operating systems, right? That kind of thing. Establish sustainable analytics process, and then keep tracking your model performance and retrain if needed. That is a very key thing, because over time the models may deteriorate, so you have to keep tracking their performance over time. And then obviously conduct just-in-time training for citizen data scientists to democratize the use of analytics within the organization, right? So analytics, it's a common myth that people think that analytics is only for a handful few people in the organization, which is not true anymore. So it has to be democratized, and that's where roles like citizen data scientists, business analysts comes into play, where they are also part of the analytic community, right? So the right approach involves this well-defined process to develop hypotheses, understand data, leverage data science techniques and algorithms to diagnose and optimize, communicate insights effectively, and implement and operationalize recommendations. Now, as we saw, that data science problem solving is a very iterative framework, right? It is not you don't get the right result at the word go, right? It has to be kind of a trial and error process. You have to iterate through different versions of your model until you achieve the required. So you start with this defined analysis objective. So what is the business question? What is the business problem which you are addressing? So you start understanding that first, and ensure that because there are going to be different stakeholders for a particular decision point, right? So you need to ensure that all the stakeholders are aligned before significant investment in analytics is done. Then you start with this diagnose problem and resolve. So you use a hypothesis-driven approach where you use collaborative techniques, chat sessions to zero in the relevant hypothesis, which is relevant for a particular business problem, and validate those and prioritize those hypotheses with your business stakeholders. Then next step is manage data. So this is a considerable effort goes in determining the information needs, gather and wrangle data. So you identify all the different internal and external data sources which are needed to solve your problem. build your models, right? Sampling of data, profiling, exploration is needed to understand your data very well. You extract the data from sources, change the data, perform data quality analysis to understand if there is any anomaly or any kind of outliers present in the data, because they may affect your model precision and uh, modeling technique itself, right? So if you identify any anomalies, you perform data cleansing, wrangling, and prepare the data for your model building. Store the data securely, consider all the master data is conformed, all these are different activities which are done. Then comes the actual model building and validation steps, where you create models using quantified and statistical models using supervised and unsmooth modeling techniques, apply use case specific statistical predictive models, and train your model and score the model to identify and iterate for accuracy. As I said, the accuracy is not obtained in the first go itself. So you have to, try different hyperparameter values, try different, types of algorithms before you get a model which gives you the desired accuracy and performance, right? And then finally, once after that, you present the insight. So whatever the your algorithms are going to predict or prescribe, you communicate that with your stakeholders using rich data visualizations through dashboards or any kind of BI tools you can do, and communicate those business insights and impacts to the relevant stakeholders to get their buy-in, right? And finally, you make an actionable recommendations, which is context sensitive and a performance driven approach. So you want to do your cost benefit analysis, the return on investment analysis to make a business case for the solution which you are proposing for a particular business problem. Uh, so the question is, I mean, data science projects do have challenges of their own, right? That is for sure. Because as we said, this is not a simple scenario. So most of the data science projects relate to handling your data and finding the right model. When it comes to data, and generally data comes in all shapes and sizes. The real world data sets can be actually very messy, incomplete, and in a variety of formats, right? There are structured data, there are unstructured data, there are semi-structured data like JSON files, XML files, which can be used for building your models as well, right? So, and sometimes it is not a simple numeric data set which you work with, but you need to combine those data set with other data types such as sensor signals, if it is an IoT related use case, text data, if it is a survey kind of situation, streaming images, speech, speech files, all of that you have to basically combine that data with your normal simple, numeric data, right? So that can be a problem also. The second type of thing is you need to pre-process your data, which may need some specialized knowledge. Just to give an example, for example, if you're trying to do an object detection algorithm, which will need special knowledge about image processing, right? That is just a simple example where you may need specialized knowledge and tools, which can be a challenge. And finally, it takes time to find the best model to fit the data, right? So the finding the best model is itself is a very balancing act. So sometimes highly flexible models tend to overfit the data by modeling minor variations. That could be a noise. Or sometimes simple models may assume too much. So there is always a trade-off between the model speed, the accuracy, and the complexity involved, right? So modeling as such is kind of a black box. You don't really know what is happening inside, but what the data is fed, and then it gives you a prediction or a prescription at the other side, right? So, but it is very important to ensure that whatever the model is predicting is ethical, is not deviating much, and so some kind of checks and balances has to be done, which makes data set projects very challenging. Uh, so sounds daunting, right? Off of this. So maybe a systematic workflow will help uh, to understand what it is actually involved. So a typical data science project workflow looks like this, right? So you start with the problem statement definitions to understand the business domain, the problem's context, frame the necessary hypothesis that fit the context, right? Uh, for example, if you are working on a credit risk analytic model, right? So you want to predict what is the credit risk for to offer a credit to a loan to a person, whether he is going to default or not, right? So that is a typical analytical requirement. So for that, you can have different kind of hypotheses, right? Uh, so you need to actually identify all the different hypotheses and also identify what kind of data you need to solve such kind of hypothesis. Right? So that is the first step. Then you acquire the data, what kind of data you identify, understand what data is required for and then you extract the requisite data from different sources and store it in your data warehouse or your data lake. So that's where the data acquisition happens. Then the exploratory data analysis. So in order in this is where it involves identifying any missing data analysis, outlier detection, kind of factor analysis, understand different data patterns, which is your there are in algorithm building, there is a concept of dependent variable and independent variable, right? So identify which your independent variables are there any collinearity between them, all those kind of analysis has to be done. So that is what is part of the exploratory data analysis. Then you have to prepare the data for your model building. So that's where your data munging or data wrangling comes into play. Basically preparing the data from its raw state for a dedicated purpose and use case scenario. And this is where you also apply feature engineering techniques to prepare the data for your model build. And after that, you actually do the predictive model building and training and scoring, okay, where you use relevant, supervised or unsupervised or any other kind of algorithm techniques, ML using ML and AI, machine learning and artificial intelligence techniques to uncover the insights and patterns on training data sets, and then validate those and score those models on test data sets and measure the model performance in an iterative fashion. Right? Once you've done that, is the final insight communication to the stakeholders. So communicate the predictive outcomes with associated probabilities, because whatever they're going to predict is obviously will come with some probability associated with them. You need to communicate all of that and use appropriate data visualization to communicate results and insights in a meaningful format to business. So this is a typical workflow, just to give insight. Finally, I would like to all of you to take a key takeaway from this session. We are almost towards the end of today's session. So decision project in a nutshell, if I look at it, basically three things. One is prepare to build a model. So, 80% of the effort actually goes in this step, that prepare to build a model. This is where understanding, building your hypothesis, acquiring the data, looking at the data assessment, and then preparing the data for all of that. So all those activities takes almost 80% of the effort. Then the actual model building, training, scoring, and deploying the model happens. And finally, the interpret and communicate the result, which has the 80% of the impact. So that is how, in a nutshell, our data set projects looks like. So I'll pause here. I will open the floor for any questions. Any questions anyone can have, please raise now. You can ask.
Great, sir. It is very insightful. Even the last slide which you showed, that it takes 80% efforts to build a model, 20% is the deployment, and it makes 80% of the impact. Very practical it happens in our day-to-day lives, and I'm sure this must be the case with almost every organization. Sir, you mentioned about in one of the slides about use case scenario.
Hmm.
So I request if we can give us some example of some use case which you must have gone through in your
Yeah, I will talk
fields.
about, for example, one interesting use case.
Sir.
This is a client in US who are into what do you call, um, basically the retail shop. They are selling clothes, right? Now, what they said is that their problem statement was that for the 3 consecutive years, they found that the sales in the summer months were declining. So
Okay.
year on year, the total sales in during the summer months, which is April, May, June, these 3 months, their sales were declining for 3 consecutive years. So
Hmm.
they wanted to identify what is the why it is happening, right? So one of the thing was, first of all, one of the hypotheses which we decide that it must be that the actual footfalls in those brick and mortar shops, right? Where they were a brick and mortar, plus they also have a small online presence where most of the sales were through brick and mortar shops, right? Stores. So one of the hypotheses is that probably in the summer months the footfalls were declining. So
Mm-hmm.
we that was one of the hypotheses. So we wanted that you share with us your footfall data, right? And what we found out that they had some issues in their footfall data. They have some incomplete data about footfalls for during those 3 months. So finally they had to reach out to actually their one of the partner who is to capture those footfall data. They reach out to them and they did some extrapolation based on which some data was captured, right? So from there we could find out that actually in the summer months the footfalls were actually declining.
Mm-hmm.
But then we also identified what happened was those the stores, for example, one store which was in a city, and then there was one store which was near to a vacation place, right?
Mm-hmm.
Like, for example, there was a store in Las Vegas. So we found that the summer months, the footfalls in Las Vegas stores was much more than the footfalls in a like New Jersey City, for
City store.
example, right?
Mm-hmm.
So what is happening, summer months, people, because the schools are on vacation, holidays, people actually go out for vacation during the summer months. So the actual people who are living in the community, they go out to some other place. So they don't visit those local stores anymore, right? So that
Mm-hmm.
was another reason which we found out. And then we also found out based on affinity analysis that the sale of luggages, right? So they also had luggages like suitcases and all those things as part of their merchandise. So those sales went up during the summer month, but actual, sales of coats and dress materials were lower. So which we found out. So we found out some really interesting data points based on different kind of analytical techniques which we use, right? So just to give one simple example, where you know,
Correct. So these,
basically
if I'm not
starting
wrong,
from an hypothesis, getting the data, and then applying, machine learning algorithms, all these kind of insights were generated, and then accordingly, some actions were taken by them.
so what I understand is if the same model can be applied to all different kinds of merchandising stores and shopping malls in India as well. Even this
In
could be
fact, in
applied to
India,
might
there
be.
was interesting. In fact, if you remember earlier, we had this big bazaar,
Hmm.
which is now not no longer there, right?
Yes.
So one big business shop in Orissa, based on that market basket analytics, right, which is an affinity analytics technique, it was found that one big bazaar shop in Orissa was selling the maximum number of Kellogg cereals. That was
Okay.
a very interesting observation based on market basket analytics, which was found out. Then on double clicking that data, right, why it was so. So it was found that there was one organization who decided to do charity work, and their charity items, they were basically distributing Kellogg cereals to the poor and needy in that area. So they brought out all the Kellogg cereal packets which was available in that store, and they used basically distributed that into the poor and needy, right? So that
Okay.
was a very interesting, observation which was found out because of that market basket analytics which was done.
Okay.
So just to give an example.
Yes, sir. So this I think methodology could be applied to maybe a Maruti distributor, or maybe the sales of a vehicle in a particular city or a district. This could be applied probably to a kind of a hiring which is happening in a particular region.
Mhm.
So various examples, kind of food being served on weekends and might be into the weekdays. So I
I
think there
can
is a
relate
lot of
another very interesting. I think this is a well-known thing, which I mean, this was not done by our company, but one very interesting anecdote that Walmart, right? Walmart in USA, they did this market basket analysis and found out that young fathers in the age group of 25 to 30, when they go to buy beers during the Friday week evening,
Hmm.
also buy diapers. So
Okay.
that was a very interesting observation, right? So they found
Right.
out that fathers who will like to spend the weekends having a lot of drinking beers and other alcoholic products, when
Hmm.
they go to Walmart to buy those, they also buy diapers because they have kids in their home, right? Infants, in fact. So what they did, this was finding from the analytics, and what was the outcome of this finding is that they changed the floor design and put the rack of the diapers very close to the rack of the beers, right? So they
Hmm.
put this too close, which made it very convenient for those the prospective fathers to pick up the beer crate of beers as well as the pack of diapers in one single move, and which actually help to increase their
Same
sale
volume.
volume as well, right? So
Correct.
this is just some few very interesting anecdotes based on analytics, which was unearthed, right? The insights were gathered.
Perfect, sir. Perfect. So, dear aspirants who all are there present, please note that all these kind of case studies will be discussed, will be explained, will be there would be a pure discussion happening around all these kind of different use cases, so that when you learn these all tools and techniques in the diploma organized by Symbiosis Center for Skill Development, you will definitely gain a lot, and that you can apply in your existing organizations. If possible, we'll also do some live studies if your organizations permit to do so while doing this diploma in decision management. Sir, thank you so much for
Yeah,
spending
and just to
yeah.
encourage in this diploma in decision management course which we are going to launch, right? There are 6 courses. One of them is dedicated totally to this end-to-end methodology of a data science project, right? So,
Correct.
starting from an analytics, design, development, testing and implementation, right? All of these. What are the different tasks and activities done? What are the deliverables which are produced during such phases? So a detailed one single course is totally dedicated for an end-to-end data science project delivery kind of methodology topic, right? So just to inform that, and
Right.
this is
Right.
yeah.
So, aspirants, our next webinar is scheduled on 2nd of August. We will again have Arup there with a very interesting topic. Definitely, you all will get insights about what is the topic and other details on your WhatsApp. So stay tuned. Thank you so much. Thank you, Arup, for this insightful session.
Yeah, thanks.
Thank you.